This is the DaVinci Resolve Speed Editor. For the moment, included for free with any purchase of DaVinci Resolve Studio, which I kind of had to break down and buy. I've already unpacked and played with this a little bit, put it back in the box because I kind of wanted to do an unbox teardown, and yeah, by teardown I'm going to take the whole thing apart. So let's see what the box tells us first. Got a nice bit of packaging here. We got a little pseudo timeline going here. Let's see. Let's turn this thing upside down. All of the marketing blurb. Let's take a quick little zoom in. So down here we've got the regulatory marks. I'll get into that more later. But those are all generally indicators of geographies in which this is approved. Because of the type of device, you probably don't need much in the way of approvals beyond just EMC, electromagnetic compatibility. So how does the radio stuff work? Let's open it up. See what we got. Got some decent packaging. It's not a device that needs a huge amount of protection, so that kind of foam is alright. We got the actual device itself. A lot of people have done reviews of this. Blackmagic has a introduction on their own channel. I will link to below. Nice little editing panel. Has good tactile feel to it. It's got some stuff on the back. Yes, I blocked out the serial number because privacy, yada yada. We'll set that aside for the moment though. Rest of the packaging. We've got the marketing blurbs. Some nice stickers that Blackmagic gave us. I feel suddenly inspired to put one of these on my laptop and sit in a coffee shop drinking a chai latte with it's my cheat day, you know, so a little bit of coconut milk. Anyway, nice bit of packaging here, nice bit of padding. Oh, yeah, so what's kind of cool about this is number 4, polyethylene PE. Polyethylene, it's kind of a neat material. It's a lot easier to recycle, a lot more environmentally friendly than polystyrene. Also, you get it nice and hot and it starts to smell a little bit like candle wax, so it smells a lot better than burning polystyrene. So, advantage there. And the rest of the box. I think I need to take a box apart for y'all. Sorry. Alright, back to the thing in question. We've got just a nice panel. Aesthetically, it's nice. This wheel is beefy. Buttons are all pretty nice. They got a nice tactile feel. They're not those old IBM keyboard clicky switches, but still feel pretty good. A little bit better than like your standard keyboard these days. So good on them. Let's get into the back. Let's see what all this means. So we've got a couple of anti-skid pads, a couple of screws to get on the inside, and then all the regulatory marks. Feel free to fast forward a little bit because this may be a little boring, but I will make it quick. So all these pretty much say this device has been tested and complies with certain geographies regulations, and because this device is pretty simple, it doesn't have any mechatronics in it, no motors, no high voltage, it's all battery powered. You don't have to do a huge amount. It's mainly what does it emit from an electromagnetic standpoint, and that's what most of these geographies care about. So let's see, first we got ourselves, it's not going to be visible, let's find ourselves a better pointer. Alright, first we got ourselves some CE, Conformité European, so European Common Market, does what it's supposed to do. They've tested it through a notified body. Actually, they probably tested this thing once or twice and collected all the data they need to then do the filings for all of these different geographies. So we got CE, we got the little triangle with checky box and circly thingy going, and that is going to be the Australia, New Zealand RCM mark. Then we got this little trash can with the X, because it's got a battery, you got to put that on, don't throw it in the trash, recycle it. In the US, a lot of people are going to ignore that, whatever. But yeah, if you think about it, then pop the damn thing apart if you're going to throw it away, and get the lithium-ion batteries inside recycled. EAC. EAC is an interesting one. I actually don't see that on a huge number of products. That is the Eurasian conformity mark, so Russia and many of the former Soviet states. KC is Korea. FCC is the Federal Communications Commission, that's United States. And we got this little ICES NMB thing, and that is Canada. And then this fun little circle with the bolt and the ground symbol, or capacitor symbol, I don't know. Nice and abstracted, that's Japan. And then, let's see, we'll move back over to this little thing that looks like a factory that says ID in it. This is not a conformance mark as far as I know. I think that's a country of origin mark. I've seen other DaVinci or Blackmagic products that say SG in it. I know some of the cameras are coming out of Singapore, so I think that's just their country of origin mark. And then down here, we've just got the FCC ID and other stuff. That leaves us with this little corner here, which is the most interesting, actually. And that says contains Silicon Labs Modello BGM113. So Silicon Labs BGM113. That is a really interesting little device. So before I take these screws off, pop the whole thing open, I want to talk a little bit about that. So, Silicon Labs BGM113 Wireless Gecko Bluetooth Module Datasheet. This is a nice little thing that you can connect via USB-C or via Bluetooth. Doing your own Bluetooth chipsets from the ground up for all that radio communication stuff gets really expensive. So your volumes are relatively low, and by that I mean like less than 100,000 units a year. Maybe even less than 50,000, it makes sense to get an off-the-shelf module. So let's set this aside. This has a nice little block diagram of what's going on inside of the module that is inside of the speed editor, and it's kind of a neat setup. They not only have integrated wireless Bluetooth connectivity, but also a ARM-based processing unit, so that you can control a device, and it's got the whole thing: antenna, I/O, serial interfaces, so you can link up with I2C, UART, and I'll get into that on the inside, but it's pretty much for the layperson. This is your computer, and your computer's going to talk to all your peripherals being these little buttons, the wheel, USB-C, battery, whatever else. So, neat little thing. So, this is the actual kind of, I'll call it a block diagram. We've got our radio transceiver, we've got our energy management, so put whatever voltage within reason you want into it, and it'll do its DC to DC conversion, step up, step down, make it right for the rest of the chipset or system on board. Got some clock management. Clocks are important. Got to keep everything synchronized so it can all talk to each other at the right way, right time. The ARM processor, all your digital peripherals. One of these is a setup that allows you to read a quadrature encoder. So I'll be interested to see if this little thing is connected on the underside to something that automatically reads out over I²C, or whether it's putting out like an analog signal. So we shall see. Let's get into tearing this thing apart. Alright, I'll put this sucker up on... maybe I won't. Try and put the sucker up on some blocks. Give it a little bit of support so it doesn't roll around on that wheel. Those screws, T15. No. Take a risk here and assume it's a T10. Happens to be a T10. They feel like nice little plastites. Okay. We definitely have some tabs going in there. Try and keep this thing together. Try and keep people like me out. Oh, I hope they didn't put screws under here. I gotta take the sticky pads off. Luckily, I have some extra VHB sitting around. That's tragedy. Now they definitely won't let me return it. So y'all better subscribe. This YouTube channel eventually has to pay for something. Let's see if they use the same size screws all the way around. Ah, good on them. 2, 3, 4. Keeping the bill of materials nice and simple. Now, alright. Should come open nice and easy. Well, the case was a little bit more of a struggle than I wanted, and what do they have here? Oop. Well, we're going to detach a battery in here real quick. Alright, battery first. Battery first. We got ourselves a rechargeable lithium-ion battery in a 18650 form factor, 3.7 volt, 2800 milliamps. Pretty typical. Since we were looking at plastics earlier, this is a PC ABS, so ABS plus polycarb, not glass filled. Interesting little bit of wear around it. Looks like post-injection they just did some cleanup. It's pretty typical. Now this is pretty interesting. This battery looks like it has its own charge control tucked into it. I'm not going to cut the battery apart because I do need to use this thing to make some videos. So they might have just avoided everything board-wise with respect to charge management and just left it on the battery cell, which is not unheard of. So we've got ourselves a PCB here, we've got ourselves the whole encoder mess here. We'll have to dig into that. And another Blackmagic board here. Somewhere buried in all of this is going to be that BGM113 module. Let's see if we get, oh, we get lucky. They are still using the same T10 Torxes all the way around. So, flipping it over to show what we have, we've got the wheel, we've got these 5 buttons, so 5 buttons on this board, 1, 2, 3, 4, 5, the wheel, and then everything else on this board. Got some kind of switch there. I don't think I need to push that. Got a little controller there. And Blackmagic, copyright, all the rest of that. Speaking of compliance, way down here we've got our Underwriter's Laboratory Recognized PCB. That's not everything put on it, not populated, that's just the printed circuit board assembly itself with a V0 flame rating and the listing info. How this PCB is attached. Well, how it's referenced is nice. They've got a reference pin here and a slot here. Some mechanical engineer has obviously impressed upon the electrical engineer the importance of basic kinematic constraint. So that's good. So the interesting thing about this is we have this piece of sheet metal that is all the way around powder coated, which is interesting that they would choose to do sheet metal powder coated as opposed to just like a 3.0, 304, 3.0 whatever stainless. And we have to take that off in order to actually see what the heck is going on. And to do that, my fear is that we have to take this off. So we're going to take this off. It's got a nice bit of rubber around it. No jokes, please. So let's peel that off. And looks like we got a set screw holding it on. Let's see if I got a bit for that. Nope. Something smaller. And something bigger. Just right. This is like a fairy tale. Okay. Ooh. Now we're getting all fancy. That is a beefy bit of hardware. Okay, so it's all lifting free except about this point here. Oh. Sticky rubber bumper. There we go. Just pop that out. Actually, I'll set that aside for a second. So yeah, they got all the texture in the plastic with a little bit of silk screening there. It's interesting, this is not cheap silk screening because we've got our white, our gray, and our orangish burnt umber all going. So interesting that they not only are making something pretty beefy, but also putting the money into representing the brand well. Anyway, let's see what we can discover here. I might not be able to pop this board all the way off without risking damage. There's a lot going on here. See, so we've got our two PEMs that are the locating features for this board, two more PEM inserts for that board. I mean, all in all, pretty nice construction. I really want to see the other side of that board, but I don't know if that's feasible at this point. Looks like this whole assembly snapped through. So, -1 for repairability. However, let's take a little zoom adventure here. Alright, so what I'm going to point out is we've got our main communication here, the USB-C ports, management for that. Another chip here that goes to all the various buttons, and between these two rows of keys, right here, that is our nice little combo module, our BGM 113. Now what's impressive about it is, let's see, in freedom units we're at like 3/8 of an inch wide. In real units, a little over 10 millimeters, maybe 10 millimeters. That's the module right there. That is our BGM 113. Is just that little bit of thing sticking up right there. That's where all the magic is. So it looks like my assumptions were more or less correct, that that's what they're using. Let's see, as we talked about, the battery's using its own little lump here of power management and charge management. Alright, let's keep going with this. Those are in nice and tight. Whoever did the mechanical design on this did a fairly good job. Short screws, easy to handle. I don't know which CM they went with, but either they have a good DFM design for manufacturing sense, or they went with a CM that's pretty experienced at guiding that process, and kind of based on the whole thing being at least assembled in Indonesia, some of their stuff being done in Singapore, I would guess that they're with, you know, Sycor, OSI, potentially Jabil, who has factories in both places as well. Alright, so this encoder unit, let's see if we can get a little bit of focus on this and talk about it. So this has its own part number, copyright 2000 something or other, same tags on it. They really only wanted to deal with processing one side of the FR4 or Garolite or whatever the heck the base is. So let's see, electrically we come in here, we got this which is unused. So again, this may be something they use in another product. It's their own PCB. This part in here is where things get really interesting. I'm going to take the risk. I'm going to take that apart and see if... Ooh, we are still on T10s. Let me get this in frame first. So, it's pretty interesting. Blackmagic proprietary board. Whatever's happening with the encoder stuff is coming in here. I can see in that gap right there, there's some stuff coming up. Surface mount off the board into this encoder assembly. I'm going to do something stupid and take this apart. See a lot of plastite screws where the actual holes in the molded plastic are not sized correctly for the screws. And it appears as though they, at the very least, read the spec sheets for the screws they were going to use. So, good on them. Set that aside. Okay. Let's see, we got an E-clip here holding a spring down because this whole thing, hard to press without the whole big knob on it. This whole thing is a switch for those of you that handled the panel before. It's got a nice bearing in it. It's a little small for one of those, whatever they are, standard size skateboard bearings, but it, I suppose could be. Now, I'm not going to get anything from that side. Luckily, this is symmetrical, so it doesn't matter that I screwed up and did not mark where it needed to go. So we're going to put this back together, flip it over, take it apart from the other side, since there's nothing to be learned here. Give it a spin, still spins freely, flip it over, and we got tiny little Phillips. Close enough. Yeah, it kind of annoys me. They've got posi drives here, tiny little Phillips here. Okay, so I'm going to hold on to this, keep it pretty tightly aligned, because I don't know how this connector is done. Now, no. Alright, so we got a chip in the middle here, and that chip is something little. Might be like a little Hall effect sensor. It's probably the way they're dealing with this. Yeah, that's my guess, is that they've got on this thing little Hall effect sensor going, and little magnet on that. So let's see, you can kind of determine that from the alignment. Well, again, we got our good mechanical sensibility going here. We've got, to align this part, 2 pins and a hole and a slot. So again, the mechanical and electrical sides have come to some kind of peace and agreement in our times. So I'm assuming that quadrature output off of that Hall sensor feeds analog signal back into this board, taking advantage of the PCNT input on the BGM 113, and that's how this nice heavy knob flicks back and forth across your timeline. Cool. So that's our disassembled DaVinci Resolve speed editor. Most interesting portion of it being, of course, this whole amalgamation of stuff. We've got our little aux board here, which I think is leveraged from another product for a little 5-button section. We've got our main portion of the system here with our USB-C plug, and as I mentioned, the little BGM 113 Silicon Labs module that they have taken great advantage of through this entire thing. Here we have a standard 18650 battery with what appears to be its own chip, and we can at least take that out. It's got a part number on it. Does not have a manufacturer code or anything. I'm guessing you can find this off the shelf if you need it. It's a pretty standard connector. And PCABS on the top. This thing, also PCABS, obviously different different material, or at least some tinting in it. It's great texture that they got. Not quite sure how they did that with the mold. It's really nice finish work. Silk screening in 3 different colors on it. And then we've got our encoder set up. So we've got a nice little slip ring. This is a nice piece of injection molded plastic. I turned it inside out. We've got, it's probably a TPU or something. It's got ridges on it that interlock with features on the wheel itself so that it will last significantly longer, won't slide around. So nice little details there. Wheel, just a nice honking chunk of anodized aluminum set screw in it that interfaces with our little encoder body. This is just all mechanical, just a bearing, nothing more than a bearing. Got a neodymium magnet on the back, which is, I don't know how that's polarized. I might see if we can see how that's polarized. And then we've got, of course, our encoder board, which has a little, I think, Hall effect sensor, outputs quadrature back to this. Let's take a little look at this. Oop. Yeah, we got some power on that magnet. If I hold this off to this side, it's attracting one pole, and then hold it off to this side, it's attracting the other pole. So it's got interesting polarity thing going there to make it work right. So the other thing to kind of be aware of with all of this compliance stuff is that these all come together to give an indication of the markets that Blackmagic is targeting. So we've got Europe and Australia. Obviously they're an Australian company, so wouldn't surprise me one bit that they are going to serve their home market very well. Eurasia, Korea, US, Canada, and Japan, but I'm not seeing any individual marks here for entities elsewhere in the world, which means that either they have worked with their compliance folks to ensure that there's mutual recognition of these with the other global markets that they're targeting, or they just don't care. And that's the Resolve Speed Editor. I guess I should put the damn thing back together and edit this video. Alright, before reassembling this, I couldn't help myself and had to go do a little bit of quick research. Let's start with the encoder. So that nice heavy wheel that we all get to play with on this control surface has this little Hall effect sensor on it, and this is what it actually is. It's a couple of $1 part, 12-bit contactless encoder with incremental quadrature output. So pretty much exactly what they should be using to get nice responsiveness out of that wheel. And it has a push output as well. So they are able to sense not only that output that quadrature signal, but also output something based on the gross magnetism. So when you push that wheel in, it also trips another signal, which kind of explains why this thing is a 8-pin package as opposed to a lot of Hall effect sensors, which are significantly fewer than that. So yeah, nice little thing. Outputs I2C, which brings it right back into that ARM chip on the BGM113. So also low power mode, so they take better advantage of the battery stuff. So that's kind of cool. And then I needed to look up that little thing because I wasn't sure quite what it was doing. And that is a little teensy ARM MCU, still 32-bit, so probably commonality in programming and all the rest of that with the module that's right under here on that Silicon Labs unit. And I'm guessing they're just using this as more I/O than anything else to all of the various switches, so it kind of makes sense to me. And has really nothing too much else interesting in it. It's just a little thing that can chat with that main chip. I2C, UART, take your pick, can. So yeah, I guess you could probably kit bash and hack the heck out of this and make it do something with your car if you wanted to, or industrial controls. So kind of neat. So now I really do have to put this whole thing back together. Usually I at least like to think of myself as fairly mechanically adept. Sometimes I'm not. I didn't take too many notes taking this apart because after all we only have on the table 7 components plus a bunch of screws, so I should be able to do this without too much difficulty. Resolve panel, done.